Hello students, today we are going to take the question based on the converse of midpoint theorem. Let us discuss what is converse of midpoint theorem. The line drawn through the midpoints of one side of a triangle parallel to another side bisects the third side. Now if we consider that D as the midpoint of side AB and DE parallel to BC, in that case the line segment this DE will bisect the third side, that is it will bisect the AC. So if D is the midpoint of AB and DE parallel to BC, then the line segment DE will bisect the third side, that is AC. It will bisect the third side, that is AC. That means AE will be equals to EC. This is known as converse of midpoint theorem. Now let us solve the question based on the converse of midpoint theorem from the exercise 8.2. Now let us solve the question number 4 of exercise 8.2, which is based on converse of midpoint theorem. Now in this question it is given that ABCD is a trapezium in which AB is parallel to DC, BD is a diagonal and E is the midpoint of AD. E is the midpoint of AD, that means these two are equal. A line is drawn through E. This line is drawn through E which is parallel to AB, intersecting BC at F. We have to prove that the F is the midpoint of BC. We have to prove that this F is the midpoint of BC. Now we will be using the converse of midpoint theorem to solve this question. Now in the question it is given that EF is parallel to AB. This line EF is parallel to AB. So EO will also be parallel to AB because a part of parallel line is also parallel. EO is parallel to AB. And in the question it is given that E is the midpoint of you can see here E is the midpoint of AD. E is the midpoint of AD and this line is parallel to this line. Therefore, this EO will bisect the side DB. That means, therefore, we can write DO is equals to BO, and this is due to converse of midpoint theorem. Converse of midpoint theorem. Now in this, EO is parallel to AB and E is the midpoint. So the line segment EO will bisect the third side, that is BD. Therefore DO will be equals to BO. So we can say that O is the midpoint of DB. I will mark it as number 1. Now in the question it is given that ABCD is a trapezium. So AD will be parallel to DC. Also EF is parallel to AB. EF is parallel to AB. So now this EF is parallel to AB and AB is parallel to DC. So we can say that therefore EF will be parallel to DC. So this EF line will be parallel to DC. So a part of parallel line, that is OF, will also be parallel to DC. Now this OF, this line is parallel to DC and we have already proved that O is the midpoint of DB. O is the midpoint of DB. Now since O is the midpoint of DB and OF is parallel to DC, then according to the converse of midpoint theorem, the line segment OF will bisect the side CB. So therefore CF will be equals to BF, and again the reason is converse of midpoint theorem. Since CF and BF are equal, so we can say that F is the midpoint of BC. So by using the converse of midpoint theorem, we have proved that F is the midpoint of BC. Now let us solve the question number 5th of exercise number 8.2. In a parallelogram ABCD, E and F are the midpoints of AB and CD. ABCD is a parallelogram given and E and F are midpoint of AB and CD. And we have to show that the line segment AF and the line segment CD trisect the diagonal BD. So that means it divides into three equal parts, DP, PQ and QB. So we have to prove that DP is equals to PQ is equals to QB. Now in the question it is given that ABCD is a parallelogram, and we know that the opposite sides of parallelogram are equal and parallel. So DC is parallel to AB and DC is equals to AB. So a part of parallel line, that is FC and AE, will also be parallel. Now half of DC will be equals to half of AB, and half of DC is FC because F is the midpoint, and half of AB is equals to AE, and because here E is the midpoint. So now FC is parallel to AE and FC is equals to AE. This side FC and AE are equal as well as parallel. So therefore we can say that AFCE is a parallelogram. So we have proved that AFC is a parallelogram, and we know that the opposite sides of parallelogram are parallel. So we can write AF is parallel to this, AF is parallel to EC. Now I am dividing this into two parts. Now since AF is parallel to EC, so a small part, that is FP, will also be parallel to CQ. FP is parallel to CQ, and here that is EQ is parallel to AP. AP is parallel to EQ. And also it is given in the question that E is the midpoint of AB. E is the midpoint of AB. Now since this is E is the midpoint and this line are parallel, so the line segment EQ will divide the PB into two equal parts. That means PQ is equals to QB, and the reason is converse of midpoint theorem. Converse of midpoint theorem. Now this E is the midpoint here and this EQ is parallel to AP. So the line segment EQ will divide this PB into two equal parts. Therefore PQ is equals to QB. Similarly here also F is the midpoint. This is given in the question that F is the midpoint. F is the midpoint of DC. Since this is a midpoint and this line FP is parallel to CQ, therefore the line segment FP will bisect this DQ, the third side, into two equal parts. So therefore DP is equals to PQ. Now we'll mark it as number 1 and we'll mark it as number 2. So now from first and second, DP is equals to PQ and PQ is equals to QB. Therefore we can write DP is equals to PQ is equals to QB. Therefore the line segment AF and EC bisect or trisect the diagonal BD. That means it divides into three equal parts, DP, PQ and QB. Now let us solve the question number 7 and last of this exercise 8.2. ABC is a triangle, right angle at C. It is right angle at C here. a line through the midpoint of hypotenuse AB. M is the midpoint of the hypotenuse AB and parallel to BC. So MD is parallel to BC. Intersect AC at D. So we have to prove that D is the midpoint of AC. MD is perpendicular to AC and CM is equals to MA is equals to half of AB. So we have to prove three things. Let us prove the first thing. In the question it is given that M is the midpoint of AB and also MD is parallel to BC. So MD is parallel to BC and M is the midpoint. So the line segment MD will bisect the third side, that is it will bisect AC. That means AD and CD will be equal, and this is equation number 1. This is due to converse of midpoint theorem. Converse of midpoint theorem. So therefore we have proved the first part, that D is the midpoint of AC. Now since AD and CD are equal, we have proved by converse of midpoint theorem, therefore D will become the midpoint of AC. Now since MD is parallel to BC, therefore angle 1 will be equals to angle ACB. That because these two angles are corresponding angles and we know that the corresponding angles are equal. So angle 1 is equals to angle ACB and angle ACB is equals to 90 degree because it is given that it is right angle at C. Also angle 1 plus angle 2 is equals to 180 degree. So angle 1 is 90 degree plus angle 2 is equals to 180. So angle 2 is equals to 180 minus 90. So angle 2 is equals to 90 degree. Now we have proved that angle 1 is 90 degree. So we can say that MD is perpendicular to AC. Now we have proved the second part also. Now for proving third part, we will be taking the two triangle. In the triangle CDM and triangle ADM, we are going to prove these two triangles congruent. In triangle CDM, you can see CD and AD are equal. So CD is equals to AD. It is proved in first. And angle 2 and angle 1 are equal because both of them are equals to 90 degree, that we have proved here. Angle 1 is 90, angle 2 is also 90. And also DM, or you can say right, MD equals to MD common. So now these two triangles are congruent. Triangle CDM is congruent to triangle ADM by the rule known as side angle side congruence rule. This is side angle side, side angle side. So they are congruent by SAS congruent rule. Now by CPCT, CM will be equals to this, CM will be equals to AM. Okay, but this AM is equals, because M is the midpoint, so AM is half of AB. So we can, this is due to CPCT, corresponding parts of congruent triangle. CM is equals to AM can also be written as MA, and this MA is equals to half of AB. This is because that M is the midpoint, so MA will also be equals to half of AB. So CM is equals to MA is equals to half of AB.